All right, so to get started, this morning our first presenter, I'm pleased to introduce is Pavan Kumar, who's the founder and CTO of Cocoon Cam. And Pavan is a leader in using computer vision for biometric detection. Got some very interesting stuff he's done in the past in that space. But more recently, he's applied that technology to his new company, Cocoon Cam, and he's going to tell you about that. But more importantly, talk to you about how he used his entrepreneurial background and spirit to bring his product to market quickly. So without any further ado, Pavan, come on up.
Yeah, thank you. Hi, everyone. My name is Pavan Kumar, and I'm the co-founder and CTO of Cocoon Cam. So my background, quick background, I've been doing computer vision for a while. I started doing computer vision for autonomous navigation, was working on multi-camera surveillance systems, and I've also briefly spent my time at NetApp and Apple. And most recently, I started this company called Cocoon Cam with my co-founder, Siva, and yeah, it's been about 3 years now. So specifically, a little bit background about Cocoon Cam. What we do is we use computer vision and AI for contact-less health monitoring. So then that means we build algorithms to detect biometrics, like your vital signs, heart rate, breathing, skin temperature, systolic blood pressure, from cameras in infrared at a 5+ foot distance. And we have the first product in the market today, which is a baby monitor system. And specifically in this talk, I'm going to talk about how we leveraged our expertise in cloud-based computer vision and launched our product to market right now. And the reason why this talk is of significance to me, but also for in general, is because first and foremost thing is when you think of cloud computer vision, and in the past it has been thought that first of all it is very, very expensive. Second thing is the latency is too high, so you cannot really build a consumer product with it, or in general a product that requires a real-time response. And the last thing is the cost is so high that it is just prohibitive to even think of doing a cloud-based computer vision product. And I'm here to sort of help us think differently in that space, because right now for Cocoon Cam, we're actually doing 100% of our compute in the cloud. There is actually no processing on the hardware at all. So yeah, let's get started. So to talk about again what we do before we go to how we got here, first and foremost thing is the problem that we are trying to address is again in baby monitoring system. It all started when my co-founder Siva had his baby daughter Lena. Like other parents, he was in the hospital, brought her home, and soon realized that he is completely responsible for the safety and well-being of his newborn. And specifically when he was transitioning from hospital to home, when there is 100% of the time monitoring in the hospital to nothing in the home, that's when a lot of parents go through anxiety, especially when his daughter was a lot cranky. He was always thinking, is my baby okay? And that's why, like every other parent, he went and bought a video monitor, a video baby monitor, only to see this. On the left, what you see is not a picture, but there's a video of a perfectly healthy baby sleeping in the crib. It actually causes even more anxiety because you don't know whether the baby is okay when you're especially looking at that video. And to look at this problem further, we actually went and spoke with over 300 parents within about 45, 50 days, and realized that parents don't feel, again, comfortable with existing video monitors. And the last thing is they also don't feel comfortable putting wearable electronics on their newborn sensitive skin. And that's why we decided to do something different, and we tried out all different sensors, including we started looking at different kinds of wearables. We started looking at ultra-wideband radars, and who wants to put a radar next to a baby, right? So that's why we said, okay, how can we use our expertise in computer vision to build this product? And that's what we have today. So this is the latest version of Cocoon Cam, and we've actually had this product in the market for about a year now. So first and foremost thing, Cocoon Cam does every single thing that a normal baby monitor does. It does HD video streaming. You can talk to the baby. You can listen, all of that. That's just table stakes. But then main differentiator with Cocoon Cam is that we are able to use computer vision to analyze videos and do real-time breathing monitoring and send alerts to a parent's smartphone. One of the favorite features for parents who use Cocoon Cam today is that we are able to leverage computer vision and some predictive analytics to alert the parent even before the baby wakes up and starts crying, so that the parents can be ready to take care of the baby. They really like that. And other than that, we also do interesting things like, again, building a nice clip of the whole night so that parents can go recap and see what happened. And so this product has been in the market, like I said, for a little over a year. And again, in the later part of the talk, I also want to share about like how we got here, how we got to market. But before that, you should also be wondering, like, how is this even possible? How do we do it? So this is, if you can play the video. So yeah, this is what we do at Cocoon Cam, right? So what you're seeing here is, again, how it looks like to the back end. We actually have about like 4 different neural networks here. There's a multi-scale neural network doing face detection. There is a body pose estimation neural network there. Then there's another neural network that is analyzing audio to understand the voice and the cry. And then there is a lot of signal processing algorithms and specifically our, like, again, sub-pixel feature learning algorithm, which is detecting those tiny chest motion that is not even perceivable to the naked eye. And we are able to extract the reliable breathing signal and transmit that to a parent's smartphone. And you can see that in this frame, you have about 22 breaths per minute. And so basically, again, this is a complex system, and obviously it is a combination of, like, you have multiple neural networks, you have a lot of traditional signal processing, and you also have some CV algorithms for tracking and image processing. And of course, like, again, there's a lot of streaming involved as well. And basically, when you have this product, I think it is similar to some of the products that you guys are probably building. And like, when we started this company about, like, again, 2 years ago, when we actually started thinking of bringing this to market, we wanted to see, okay, how can we bring this product to production, right? And specifically, these were our design constraints when we started developing. First things first, as a hardware company, first of all, hardware is hard. At the same time, hardware's funding is very sparse. So obviously, we wanted to bring this product to market with the lowest budget possible. So obviously, like, again, we have low development cost, plus also we have less cost to bring this product to production as well. The second thing is, since we are building a consumer product, the end-to-end latency is very important. Like, for a consumer product, if, like, again, let's say, for example, you're tracking a person and the latency is, like, again, more than 2 seconds, people already get very conscious there. So the end-to-end latency has to be less than that. And the third thing is, since we are actually doing biometrics, this is actually a very critical product. It's a baby breathing monitor. So we want to be able to understand the environment where it works and run real-world tests before we bring this to production. And we also wanted to, like, sort of, we had different hypotheses on what kinds of algorithms will work over extended periods of time. So it was very important that we could compare and contrast the performance of multiple algorithms and neural networks before we actually bring this to production to hundreds of users. The last thing is, again, at the end of the day, it's a consumer product, and baby monitors is a very crowded space. So the end cost to the consumer was very important. And the last thing is, like, we already, when we actually showed our systems in terms of our computer vision capabilities, we already had a lot of interest from both e-commerce and retail channels. And so we wanted to basically build a system, build a camera plus a compute platform, which can scale easily to tens of thousands of cameras without, again, additional costs involved. And that's pretty much how we ended up, like, again, going to choose our compute platform. And during that time, we actually observed 2 trends. First thing is, again, initially we started building hardware. And then a lot of things changed when we actually went to 2016 CES. When we went to 2016 CES to the IoT and the camera pavilion, if you've been there, you know that there are hundreds of camera manufacturers there. And when we were talking to about, like, 5, 6, we started observing one trend. First thing is that there is absolutely no differentiation between any of those cameras. or any of those vendors. Everyone has a camera that streams real-time video, both in H.264, Motion JPEG, or again, other formats as well. They can basically have a speaker, they have a microphone, and they are very, very inexpensive. It starts about $15 for a camera that can do all of this I mentioned. And then you can also customize them and add your own sensors if you want to that platform. The second aspect of it was about, again, while I was working at NetApp, we were mainly, again, thinking about how are cloud platforms changing. And obviously, everyone is moving from managed services to the cloud. And at the same time, there is, again, around 2016 is when there was Azure, AWS, Google Cloud, and everyone is sort of competing to get the same customer. So there was, like, again, they were driving very steep discounts. Plus, at the same time, they are giving they're giving free cloud compute credits, even up to the orders of hundreds of thousands of dollars in order to onboard a customer. So we said, okay, there should be a way to leverage this. And at the same time, again, since I had some experience there, and if you talk to any person who has built distributed cloud systems, it is actually very easy to get onboarded. It takes much lesser time compared to, like, again, building a hardware system. So we said, again, we should definitely look at this and see how we can leverage the cloud. At the same time, when we started building, thinking about what are some limitations that we have to keep in mind, and how can we really, again, build a system that can be deployed to the end user. And when we spoke to experts who have already been there, done that, again, these are some of the things that we were observing. First and foremost thing is when you think about cloud-based systems, again, everyone thinks about the cost. The high recurring cost is definitely one of those that you have to keep in mind. At the same time, also about, again, is it even, like, first of all, is the recurring cost. The second thing is, like, again, is it even possible to bring this at an affordable rate to an end user is the other question. And again, for a one-time sale product, is it even valuable to leverage the cloud? Because again, like, how long can the customer use is the question. And the second thing is network connectivity. Again, if you're, let's say, for example, building a system that does 0% of the compute on the hardware and 100% of the cloud, obviously you are dependent on that network, and that is going to dictate the quality of your service. So we wanted to run real-world tests across America, across all our customer segments, to understand whether it is even practical. The third part of it is, like, about, is the bandwidth that we consume even, like, is it okay for an end user, especially who has any commodity or any network connection across America, right? So we actually use about 100 gigabytes of video data per month in a customer's house, and that's the maximum, and it basically varies between 50 and 100. And we wanted to see is that even, like, okay for an end user. And the last thing is about the latency. Again, like I mentioned previously, if the latency is high, no one is going to use a consumer product. If you're doing tracking babies and the baby's moving around and your circle which shows the tracking is completely off, they won't trust your system. So we wanted to see how that's going to work, right? And the other aspect of it was, again, understanding whether it is, like, really cost prohibitive. So when we did the math, again, like I said, we use CNNs, we use CV-based tracking algorithms, we use signal processing. And when we actually benchmark this, we use, again, Intel Linpack benchmark for most of our analyzing our workloads. And we use roughly about, like, 5 to 10 gigaflops for our compute needs. And we have optimized that, obviously, by building our own neural networks. We don't use off-the-shelf stuff. That's one thing. And then when we were looking at, again, the cost both in the cloud and on device, let's say, for example, an Amazon T2.micro instance, it is actually a general purpose compute instance. It has one vCPU. It has about 1 gigabyte of RAM. And that gives you about 30 gigaflops of compute performance. And it costs about $8 per month. And when we can support, like, let's say, for example, we can support 4 customers in this one instance, then it's about $2 per customer per month. And that is not including, again, the other optimizations that you can do. And in comparison, a Raspberry Pi costs $35. And again, it is, if you're thinking about a customer lifetime of about 2 years, it sort of evens out. Like again, we can pretty much probably even save our cost by doing compute in the cloud versus doing things in the hardware. See, the other trend that we saw was that the cost per compute was continuously going down. Like I said, we've already seen that people were offering very steep discounts. This is, again, some of the analysis. I was not able to find proper historical pricing, but there was just one blog who was sort of analyzing how the trends have been changing over time. And you can actually see that, again, the cost right now is about 1/3 of what it was, like again, in 2011 when they started looking at this. And this is for exactly the same instance. This is not for the next generation of instances. For the exact same instance, the cost is roughly about 1/3 right now. And actually, for AWS, they unveil new types of instances every year. And if we look at the latest instance that we have, which is the T2 instance, and this, we are looking at the general purpose compute large instances, which have about 2 vCPUs and about 8 GB of RAM. And right now, the cost is about 1/5 of, again, what it was before. And another thing that I also do want to mention here is that, again, this is just about their on-demand instances. If you do want to optimize compute more, again, for reserve pricing, Amazon gives you about like 30% discount. And if you even want to save more, you have spot instances. And spot instance pricing, again, you can pretty much get about between 8 to 10x savings by going to spot instances. So obviously, it is very affordable to actually build a product that does real-time compute in the cloud and get even better performance than the hardware itself. So when we said, again, initially about some network limitations, we actually ran pretty large benchmarks. So we actually gave out about 200, 300 cameras to customers all around America and ran benchmarks. And we observed, again, over 99% uptime in, again, commodity internet connections. So that's not bad. At the same time, we actually just tested very simple systems where we had our server set up in San Francisco, and we measured, again, latency for the end-to-end compute. This is basically the frame being captured on the camera, leaving the camera, going to our cloud servers, and the analytics coming back to your phone. And that was constantly under 5 seconds. And this was without any optimization. And when we were looking at, again, what is the bandwidth requirement, when we were looking at, we were actually trying to understand whether we need to stream like 720p video to do everything that we want to do. Turns out, no. Again, if a lot of you work and build neural networks, you actually can get the same performance even if your image is compressed. So right now, we just use 360p video for all of our compute to get all the biometrics that we do right now. And the maximum bandwidth utilization, even if two parents are like streaming it on their phone applications, plus the constant uplink to the cloud, is about 200 gigs. And turns out that most internet providers, including Comcast, they have about 1 terabyte of limit for general use. So again, we are well within that limit. So again, because of that, we actually decided to take that risk and say, can we build that cloud infrastructure that can basically support all of this? Right now, I'm happy to say that we are actually processing about 1.5 petabytes of real-time video per month, and from our thousands of cameras deployed across users, and the end-to-end latency is less than 3 seconds. So what I want to show you in this slide is basically, like, again, what are we using for compute, right? Some of the ways that you can get the best latency end-to-end is for compute. We are basically, again, for all the general purpose compute, we use EC2, which is the class of instances. You can get GPUs with it. You need not use GPUs. We only use CPU, because of which we actually save a lot of cost. And I'll show you how we can actually optimize our costs as well. And the other thing is we also use Amazon Lambda, although Amazon Lambda is only useful when you actually have bursts of compute required. Let's say, for example, for whatever reason, you want to run a million jobs at the same time. Amazon Lambda lets you do that instead of you spinning your own job servers and managing that. And we had to do that for a given extent, and right now we don't use it as much. And for the data pipeline also has to be extremely efficient, because when you're looking at this end-to-end latency, again, this is already available. This is not something new. But when you go and, again, talk to any distributed systems engineer who's like building systems right now for any major companies, you'll actually hear about all of these technologies. So we use Kafka for data pipelines. We also do leverage Spark as well most recently. And we use Cassandra for a lot of our heavy write operations. And this is already known. I just want to say that, again, this is already available if you want to build a very efficient data pipeline, which even takes, like, again, like right now, our data pipeline itself has about, like, again, 600 milliseconds of latency, and that's it. And actually, again, if I can play that video, that's pretty much what the end user sees. And it's fine. So basically, again, what I wanted to show you in that video, if it was there, was even if the baby starts moving around the frame, the circle actually tracks the baby, and you can actually, it is the movement and the latency is pretty much imperceptible for an end user, and they're pretty happy with our systems right now. And the other aspect of building real-time systems, especially leveraging the cloud, is how can you minimize latency, right? Like I already mentioned, building efficient data pipelines is the #1 thing. We actually did experiment with a lot of different technologies and systems to both, again, the first part of that system is, of course, managing your data from the time it reaches your server to the time it, again, gets out of your server as well. But having said that, again, that the endpoints as well are equally important, which is basically how does your system take in frames from your cameras, and that system now has to be, again, low latency. At the same time, how do you maintain that reliable stream of processed data, and how do you pass that on from your server to the end user? Again, there are systems available already, but again, doing that in real time with thousands of cameras, again, we had to basically figure out how to do that. At the same time, one of the technologies that helped us a lot in scaling was containerization. And one of the reasons I want to mention containerization is because although we did start with AWS, right now we're actually cloud agnostic, and we pretty much have our compute deployed wherever we get the best cost per compute. And because we leverage containerization, we can pretty much move our workloads with literally a button on our dashboard. And it's that easy. The second thing is about minimizing latency is about using storage, again, which is unlimited in the cloud, right? If you're building systems in the cloud, you can pretty much have microsecond, even millisecond level, microsecond level latency for accessing data, which pretty much means that you can pretty much extract hundreds of parameters per frame and actually have that available throughout as long as you want. And that is pretty much not possible on the hardware unless you have a bulk of, again, a big NAND right next to your hardware, which can, again, increase cost. And the reason that is important is because that temporal information itself can actually increase the accuracy of your system itself. Let me give you an example there. For example, one of the things that we actually do in order to measure sleep information is, again, we have to find out which exact time is the place when a person came into the frame, slept on the bed, how long were they in the bed, and then when did they get out, right? And since you have unlimited storage, we can actually go back and look at the historical information and actually understand this is the exact time when they came in. Because when you're looking at motion information, you may always be confused around, is this really a person there? Do I have to wait till a moment when I can get a confirmation? But if you can actually have that unlimited history and go back and see what happened, that lets you do wonders and lets you be much, much more accurate. And the other part of it is, again, these are things, optimizations that everyone does, which is not every algorithm has to be run in real time. Some of the things that we do there is basically once we, again, see motion, we actually run our neural networks first at that region of motion, then we run it everywhere, which pretty much, again, we are saving a lot of compute, but at the same time getting faster response from our neural networks. Plus, at the same time, we leverage tracking algorithms so that once you get a neural network lock on a face, you can track that, again, throughout your frame till you, again, have to run that algorithm again until you get those clock cycles available for your algorithm to run again. And the last part about doing compute in the cloud is how do you get the best performance from the hardware, right? When you're thinking about, again, leveraging the cloud, and when we are thinking about like being very cost efficient and only using CPU, the only again, things that are available to you are those compiler optimization parameters. And when we are using SSE MMX, we have actually observed that we get more than 3 times better optimization, especially when we are running TensorFlow models in production in the cloud. So definitely encourage you checking that out. And the other advantage, again, this is my favorite advantage of building systems in the cloud, is that you can develop faster and deliver higher quality. And actually, because of that, our engineers are super happy because they can literally deploy their algorithms to production as soon as possible. Like once the algorithm is done, they can deploy it. And basically, at any given point, we have multiple versions of the algorithm running for an end user. So it's almost like, again, you've probably heard this with Facebook, that if you are using Facebook app on your phone, like again, there are probably hundreds or thousands of versions of Facebook running in real time. And they are able to do those dynamic optimization, experimentation, and figure out which is the best one that works that has to be deployed to the rest of your users. So we actually have about, again, 3 to 4 algorithms. And again, 5% of our population runs a different algorithm all the time, so that we understand and we can basically compare and contrast different versions of algorithms. How does it perform over time? And then deploy the best algorithms to end users. So that enables us to get analysis on the impact of the algorithm enhancements. Even our engineers don't have to compete and say, again, this algorithm is better, because data proves it. And now we actually can run multiple algorithms in real time, and whoever has the best algorithm gets to put that in production. And again, the other advantage is that it reduces hardware fragmentation and testing cycles, because since everything is in the cloud, at any point, if we observe some anomalous behavior, and let's say, for example, again, this example can be for a surveillance system. Let's say your algorithm was trained to work in sunny California, and now you have to go to Boston and deploy it in snowy conditions. How do you understand, how do you basically change your algorithm instantly so that it can adapt to those conditions, right? So one of the ways that you can actually do it is by, again, having things in the cloud where you can pretty much deploy a new version of the algorithm soon. And again, you can do continuous integration, continuous delivery. It almost becomes a software company, a fast house, and you can keep moving faster. And again, the summary of what, again, the takeaway that from this talk is mainly that, first of all, like business leaders don't have to shy away from going to the cloud. We have actually deployed tens of thousands of cameras in the field, which are 100% compute in the cloud. Obviously, we are working with compute platforms right now to optimize between hardware and the cloud. And it's actually great for development teams, especially if you're working on testing multiple algorithms at the same time. That's pretty much it. Thank you.
Very good, thanks. We probably have time for 1 or 2 questions, so if you have a question, if you can make your way to the microphones, that'd be great. And while you're doing that, I'm going to remind you real quick to fill out your surveys. There's a $100 Amazon gift card for those who fill out a complete survey and turn it in. And I guess I have a question to start, Pavan. How do you deal with false positives? I mean, I got your baby monitor watching my loved one, which I totally get, by the way, because I've been through that. It signals an alarm. I'm panicking, but it's okay. So does that occur, or what do you do in that situation?
It's a great question. First of all, we can afford to have false positives, but not false negatives at the same time. So basically, we definitely err on the side of being cautious. And that's very important. At the same time, it's actually interesting, right? Sometimes, even if your algorithm is 100% accurate, for your parents, or for anyone to trust your system, they have to understand what it looks like. So although the number of false alarms is extremely low, sometimes that one false alarm, especially let's say, for example, they took the baby out of bed, we did not recognize that, but then it said there is no breathing, and then they see that, it sort of gives them trust in that system itself. And because we are doing things in the cloud, we actually store everything. So when, and customers don't shy away from complaining when stuff happens, so we can basically go back and see what happened.
You have a question there?
Hi, great presentation.
Thank you.
Quick question, did you have to deal with any regulators like the FDA since you monitor the baby?
So a great question, right? So basically, again, when we are looking at breathing monitoring and sleep tracking, right now it is like it's a consumer wellness device. And it's almost like, again, there are multiple products, like, again, there's a company that's making Fitbit-like things for babies, then there are people doing sleep tracking and whatnot, and especially if it is like a comforting thing, and specifically since we are not making FDA claims, and we specifically tell the parent that this is not a medical device at the time they purchase and they download the app, and I think they get to the intention that this is something that's going to give me reassurance, peace of mind, plus sort of help me easily transition to parenthood. So that in that sense, parents understand that this is not a medical device. This is something that is going to help them ease into that parenthood journey. Thank you.
In time for just one more question.
Excuse me. Do you charge a subscription fee and an upcharge, or do you just absorb the potential? You know, if somebody uses their camera for more than 2 years, is a bit of a risk that you're taking, and you just absorb that in the selling price?
So a great question. Again, usually again it is 2 years, just because again parents they go to out of that parenting phase, and then they don't like to have cameras in toddlers and whatnot. So that's one of the assumptions that we have definitely made. But at the same time, again, we also have some assumptions that we have, which is we don't have to be doing monitoring all the time. It's only like, again, maximum of 16 hours a day where the baby sleeps to, then it goes to like, again, 8-10 hours a day. So it's basically, we are saving a lot of compute there already. And there is definitely that risk, but at the end of the day, this model can actually work even better for products that have subscription, because you can basically ship any camera to them, and again, your cost is only, and you can pretty much have the same camera open up to multiple applications as well. But we are indeed planning on charging subscription for historical insights, basically for you to understand what were the trends over a period of time. And so it's not there right now, but it will be there in the next product.
All right, well, great presentation, Pavan. Thank you very much, and good luck with your company.
Thank you.